Hi again. Welcome to section 8.5, actually just the end of this section. We're just going to quickly go over a guide for balancing neutralization reactions. Okay, so we've learned about the equations, and we know that we have to have the same number of atoms on each side of the equation. So you can do this, but sometimes neutralization reactions can be a little bit tricky, so there's a little quick guide, some tips that you can look for when you're balancing these equations. First, you're going to write out the reactants and the products. We're actually going to kind of see how you can form your salt. Okay, remember that a neutralization reaction is an acid plus a base, which yields a salt plus water. And then we're going to, in step 2, you balance your H plus in your acid with the hydroxide in the base. And then you balance the water with, balance it with the H plus and the OH minus. And then you can write the remaining ions as your salt. I'm actually going to look at balancing milk of magnesia. So this is the main component, the base, magnesium hydroxide, that is in the antacid milk of magnesia. So you're going to see why these antacids work. So like Rolaids and Mylanta and Tums is because they have this basic component that reacts with the stomach acid in our bodies and then is neutralized. So it's a neutralization reaction to help settle your stomach, and it forms a salt plus water. So if we were going to balance the equation for magnesium hydroxide and nitric acid, okay, so first you have to write these two components down. So more than likely on your exam you'd be given these two components, so your acid and your base. And so you have magnesium hydroxide and nitric acid. Okay, and then it tells us in step 2 to balance the H plus, so that's our acid. Get my pen real quick. Okay, so this is our acid. This is to balance H plus with OH minus. So we have 2 hydroxides, so we need 2 nitric acids. Now we balance the water. Okay, so we have 2 and 2, and so we're going to have 2 waters. And then you place your remaining salt to make your salt, your remaining ions to make the salt. So we're left over with the magnesium and our nitrate, and those two form our salt. And remember that magnesium has a +1 charge, nitrate. Okay, and so if we balance our charges, we're going to come up, magnesium has a +2. That was the whole point of showing this here. And so if we balance our charges, we end up with this 2, almost like swapping charges here, but we get 2 for every 1 magnesium atom, we need 2 nitrate polyatomic ions. Okay, so we're going to select. This would be, since you have multiple choice tests, this can be convenient because you can actually go through if you were to get stuck and, put the coefficients out front and see if it will balance. Okay, but that would take a lot of time, so hopefully you wouldn't have to do that. But we're given A, B, or C to balance the coefficients for the following neutralization reactions. Okay, and so what we want to do first tells us, so we're given our acid and our base. So this is actually the aluminum hydroxide as a component in antacids as well. Okay, and so we're going to see here that we have we have 3 hydroxides, and so we're going to have to balance out that 3 for our acid, so our H plus. Okay, then it tells us that we need to balance out the water, so we have 3 of hydroxides, 3 protonated hydrogens, and so we have 3 waters. So our coefficients would be 3, 1, 1, and 3. So C would be our answer here. Okay. For number 2, this will probably be about as difficult as it will get, really. So first thing we want to do is we want to add up our hydroxide. So we've got 2. Okay. And so if we go over here and we try to place a 2, we run into a problem because technically we would have 6. So I'll put that here. So technically we would have 6 and we would have 2. Okay, so that's not going to work. Okay, so let's erase that. Okay, so basically you have to think about what your common factor is here. So we need equal amounts of hydroxide and of our protonated hydrogen. Okay, so what we can do here is we need 3 and a 2. Okay, see, we have 3 times 2, so we have 6 hydroxide, and we have 6 hydrogen. Okay. The remaining ions become our salt. Okay, remember our salt is an ionic compound. It's got our metal and nonmetal. I need to label that up here as well. So our aluminum and the chlorine combined. So you may want to go back to naming to remember how this works. I've tried to show you. Okay, but briefly. So your barium. So we'll do it for this one real quick. So barium is in group 2, so it has a 2+ charge, and then phosphate 3-. Okay, and so there's different ways you can go about calculating this, but basically you have to have your charges cancel. And so you end up actually just swapping these numbers here, so you get. So that's how we get the formula for our salt. And we did the same thing in number 1 as well. Okay. Now we have to find the coefficient for the water. Okay, so we have 3, 2, it's going to be 1 here because it combines, so it's going to be already set. It just needs 1 of our salt. And then we have to balance the water. Okay, and so if you can, since you know everything at this point, you can go through and just, add up your oxygens, hydrogens. You can do it that way. But you're actually going to need 6. Okay, so you use we had 6 here and 6 here, and so we're going to need 6 waters. So we had 6 hydroxides and 6 protonated hydrogens, and so we need 6 water molecules. This one's just a little bit different. Okay, up here everything matched, we went across. Okay, but here there was no way for us to get an even number without multiplying everything through by 3 and 2. So our common multiple was 6, and then we have to have a 6 here as well. Okay, this is just some tips for balancing. Once again, you can go through and you add up just like we've done previously, but this will just kind of help you get started, and hopefully you can balance them quickly on your exam. Thank you.